welcome back. Today we're going to be talking about solving equations, one and two-step versions. The next lesson we'll be talking about solving multi-step equations. The objective is that by this end of the video, you should be able to solve one and two-step equations. As is usual, we've got a couple definitions to get us started. The first definition is sides of an equation. The sides of an equation are the two sides of the equal sign. Frequently, I'll ask you to do something to the left or right-hand side of the equation. What that means is you can split the equation into two pieces straight up and down to the equal side, creating a left side and a right side. Solution of an equation and to solve an equation, we've seen those words before, but they're going to show up again, so I figured we'd take a look at those real quick again. Solution of equation, a value that, when substituted in for the variable in the equation, makes the equation a true statement. To solve an equation means to find the solution to an equation. So an easy example, suppose you were asked to solve 3y equals 6. To do that, well, you might figure y is equal to 2, because 3 times 2 equals 6. Suppose you're asked to solve these two equations, 3x equals 11, or 0.5x plus 2.2 equals 3.7. While you may currently have the skills to work those in your head, we're going to learn a few more skills that are going to help you to work these problems, plus some even more complicated than these. Let's take a look. The process of solving an equation is a bit like a puzzle. I like to think of it like a game. Our goal of the game, or the puzzle, is to try to get one variable on one side of the equation and a number on the other side by doing opposite operations in reverse PEMDAS order. Ooh, what a mouthful. In other words, we're going to do opposite operations in SADMAP order. In the end, our solution should look like 1x, or y or z or p or q, whatever your variable is, equals a number, such as 1x equals 2, or 2 equals 1x. Notice it does not matter which side the variable is on, so long as that you just have one of that variable on one side and a number on the other. Let's take a look at the rules of the game. The rules of the game are that you must simplify both sides of the equal sign first. You must do the opposite operations in SADMAP order, and you must keep trying and checking your answer until you succeed. That last step is extremely important because with solving equations, you can always check your answers to make sure that you got the correct solution. We're now going to take a look at those opposite operations before we start solving some two-step equations. Addition. Suppose there's addition in the problem. When a positive number is added to the variable, to do the opposite operation, you subtract it from both sides. So looking at a couple of examples of that, suppose we have 9 equals 53 plus y. Let's split our equation down the middle through the equal sign. And we have a 53 plus y. Notice a positive number is added to the variable. To do the opposite operation, remember that's our second rule of the game, we have to subtract it from both sides. So I'm going to subtract 53 from both sides of the equation. 9 minus 53 is negative 44 equals y. Notice there's just one y on the right-hand side and a number on the left-hand side. But you might be saying, well, what happened to the 53? 53 minus 53 is 0, which we do not need to add to y because 0 plus y is just y. So in one step, we solved our equation, ending up with y equals negative 44. As the rule stated, we need to check our solution. So 53 plus negative 44 should give you 9. Let's take a look at our second example. Suppose you have y plus 12.3 equals 15.3. Again, we're going to split our equation down the middle, and you notice you have a 12.3 being added to the y. To get the y by itself, in other words, we just want y right here, we're going to subtract 12.3 from both sides. 12.3 minus 12.3 is 0. Leaving us with just the y equal to 15.5 minus 12.3 should be 3.2. And there you have your solution because y is by itself on one side with a number on the other. Check your solution. 3.2 plus 12.3 is indeed 15.5. All right, how about subtraction? When a number is subtracted from the variable, or, notice the big huge or, a negative number is added to the variable. So if either of these conditions is met, you do the opposite operation and you add that number to both sides. Let's take a look at a couple of examples. First example is probably a little bit more straightforward. Suppose we have x minus 15.2 equals 3.7. Notice, negative 15.2, it's x minus 15.2. We're trying to get x by itself. To do this, we're going to add 15.2 to both sides. Let's see what happens. Negative 15.2 plus 15.2 is 0, leaving us with just x equals 3.7 plus 15.2 is 18.9, leaving us with our solution, x equals 18.9. Checking your solution, 18.9 minus 15.2 should be 3.7. All right, take a look at the second example. This one's similar, but a little bit different. Notice it's a negative 11.4 plus x equals 3.2. Again, our goal is to get x by itself, and so we need to get rid of that negative 11.4 plus x. To do this, we're going to add 11.4 to both sides. Because negative 11.4 plus 11.4 is 0. Leaving us with just x on the left-hand side. 3.2 plus 11.4 gives us 14.6. When a coefficient is next to the variable, meaning it's being multiplied, you do the opposite operation and divide the number, including the sign, on both sides. Taking a look, 3a equals 7. We want just a, we do not want the 3. So we're going to get rid of that 3 in a slightly weird way. We're going to divide by 3. 3 over 3 gives us 1a equals 7 over 3. Yes, you may leave it as an improper fraction. Matter of fact, I prefer it that way. Let's take a look at the second. Oh, forgot to check our answer. 3 times 7 over 3 gives you 21 over 3, or 7, so it checks out. 22 equals negative 5a. Again, all you want is the a. Notice the negative 5 is being multiplied by the a, so we divide both sides by negative 5. Leaving us with 22 over negative 5 equals negative 5 over negative 5. That leaves us with 1a. You do not have to write the 1 if you do not want to. And our final answer is 22 over negative 5. Alright, division. When a variable is divided by a number, you do the opposite operation and multiply both sides of the equation by that number. So if we have 4 equals x divided by negative 3, we're going to multiply both sides by negative 3. Negative 3 times 4 gives us negative 12 equal to. Now, the reason this gets rid of the denominators, because really multiplying by negative 3 is like multiplying by negative 3 over 1, giving us negative 3x over negative 3, which is negative 12 equal to 1x. And there's your final answer. To check your solution, like we put the negative 12 back in for x. Negative 12 divided by negative 3 is indeed positive 4, so our solution checks out. The next two examples are the oddballs of solving negative variables. When there is only a negative sign in front of the variable, you do the opposite operation and divide both sides of the equation by negative 1. Let's take a look. Negative a equals 2. Notice there's just a negative sign in front of the a, meaning the a is not entirely by itself because it has a negative there. To get rid of it, we're going to divide both sides by negative 1. Let's see what happens. Negative a over negative 1 is a positive 1a, or just a, because a negative over a negative is a positive. 2 divided by negative 1 is negative 2. And we're left with our solution, a equals negative 2. Other example, negative b equals negative 4. Divide both sides by negative 1 to get rid of that negative from the b. And negative 4 over negative 1 is a positive 4 equals b. Checking our solutions in both of them, negative 2 is a positive 2, so that one checks out. Negative 4, when we put a 4 in for b, is equal to negative 4, so that solution also checks out. We're now on to our last opposite operation, which is a fractional coefficient. If the coefficient is a fraction, you do the opposite operation and multiply both sides of the equation by the reciprocal of the fraction. Reciprocal is also called the multiplicative inverse. Let's see what happens. Negative 4 over 3 times z equals 20. So our coefficient is a fraction of the z, negative 4/3. We're going to do the opposite and multiply both sides by the reciprocal. 3 over negative 4 times negative 4 over 3. We have to also do this to the right-hand side. Multiply it by 3 over negative 4. Notice, it's real important, what you do to the left side, you have to do the exact same thing to the right side of the equation. This leaves us with 3 times negative 4 is negative 12 over negative 4 times 3, negative 12z, equal to multiply a whole number by a fraction, we put the whole number over 1. We multiply the numerators. 20 times 3 is 60. Over 1 times negative 4 is negative 4. Negative 12 over negative 12, we're simplifying both sides now. Negative 12 over negative 12 is 1z. 60 over negative 4 is a negative 15. We can check our solution by putting negative 15 back in for z. Negative 15 times negative 4 is positive 60 divided by 3 is 20, and our solution checks out. Alright, so we're going to use all that information plus what we talked about at the very beginning of the video in order to solve the following equation for x. Remember the rules of the game. We had to solve in SADMAP order by doing opposite operations. Let's take a look at this equation. Again, we're going to solve it by doing the operations in SADMAP order, which means we're going to undo subtraction addition first. Again, our goal is to get x completely by itself on the side that it's currently on. So, is there any subtraction or addition that needs to be undone in order to get the x by itself? The answer to that question is yes. There is a 4 plus the 2x. So we subtract 4 from both sides. 4 minus 4 is 0. Plus 2x just leaves us with 2x. 23 minus 4 is 19. So we've undone the subtraction and addition. Now we're going to undo the division and multiplication. Since it's 2 times x, we undo the 2 by dividing both sides by 2, leaving us with 2 over 2, which is 1, x equal to 19 over 2. Again, you can leave it as an improper fraction. To check our solution, I'm actually going to show you the checking process in this example. We put 19 over 2 in for x, so we get 4 plus 2 times 19 over 2 equals 23. This leaves us with 4 plus, notice when we cross-reduce, the 2 and the 2 reduce out, leaving us with 4 plus 19 equals 23. 4 plus 19 is 23, equal to 23. And we notice that the left-hand side and the right-hand side of the equation are equal when we substitute it in our solution, which means we found the correct answer. Alright, you go ahead and try to solve this equation using the reverse order of operations, or rather doing the opposite operations in the reverse order, to get y by itself. Okay, to solve the equation, first we would add 5 to both sides, because that undoes subtraction. Negative 4 plus 5 gives us 1 equal to negative 5 plus 5 is 0, giving us y over 3. Then we would undo the division and multiplication by multiplying both sides by 3. 3 times 1 is 3, equal to y over 3 times 3 is just y, or 1y, and that should be our solution. 3 equals y. You can check your solution by going negative 4 equals negative 5 plus 3 over 3. Leaving with negative 4, by the way, this is our check, equals negative 5 plus 1. Negative 4 equals to negative 4, which means we found the correct solution. There are 5 equations I would like you to try to solve on your own by pressing pause, working out the question, and then pressing play when you're ready to see the answers. Please do not forget to check your solution. Alright, for the first one, hopefully you undid the addition, notice it's a positive 11, by subtracting 11 from both sides. This gave you 11 minus 11, which is 0, leaving with negative z equals 11. Then to get rid of the negative, you divide both sides by negative 1, leaving you with, finally, z equal to negative 11. Checking your solution, you get 11 minus, putting in negative 11 for z, equals 22. 11 minus negative 11 is 11 plus 11, equal to 22. And finally, 22 equals 22, which means our solution checks out. The second example, to get rid of the negative 3/10 off of the y, we multiply both sides by 10 over negative 3. Leaving us with, notice these will cross-reduce, giving you 1 over 1, or just 1y, equals to 10 over negative 15. Reducing your answer, you're left with y equals to 2 over negative 3. Checking your solution, you get negative 3 over 10 times 2 over negative 3 should equal 1 over 5. Notice we can cross-reduce again, leaving us with 2 over 10 equal to 1/5, and 2 over 10 does reduce to 1/5, which means our solution checks out. We're on to a third example. Go ahead and press pause, work it out, and press play when you're ready to see the answer. Okay, I went ahead and worked it out. You should have added 4, then multiply both sides by 3, giving you n equals 30. And you'll find that in the end, when you substitute 30 back in for n, the solution does check out. Alright, the fourth problem, go ahead and work it out. Alright, I subtracted 5 from both sides first, then divided both sides by negative 5, giving me a positive 9 over 5 equals to y. When I check my solution, I had to put 5 over 1, cross-reduce, got negative 4 equals 5 minus 9, and negative 4 equals negative 4, which checks out. And now we're on to our last problem. It's going to look weird. Go ahead and give it a try. If you don't get it, no big deal. It's a lead-in into the next lesson. And here we go. First I reduced it, negative 6 over 3, give me negative 2. Then I divided both sides by negative 2 since it was negative 2 times the parentheses. And when we're going inside map order, parentheses comes last. Getting rid of the negative 2, got rid of the parentheses, so I could add 10 to both sides, giving me 5 as my solution. Substituting 5 back in, the solution did check out. And that's it for this video. Thank you.